So storage area networks, or the SAN, can sound really daunting as it is, but can you actually learn it very quickly? After doing it for so many years, I believe the easiest way to illustrate how it works and how to learn it is to actually draw it out on a board. So today, I'll be covering a little bit of the evolution of storage, the concepts behind it, and why storage area networks are actually one of the most important things in a modern data center. So let's get right into it. Let's start with the very basics of the evolution of storage. It all started when you have a normal server and you have drives inside of it. This is the most basic form of storage in itself. It's pretty much like the infrastructure or like your laptop, where you have internal drives, internal SSDs, and in a typical server, you have more than one. That's how it all began in a data center. As the data center grew, we needed a lot more storage. So they came out with a device called the Direct Attached Storage, or DAS. So essentially what it is really a storage with heaps and heaps of drives. This could be up to 30 or 40 SSDs or 30 to 40 hard drives historically. And what happens is that you have this connected directly to a server. As data centers grew, they wanted to optimize it further. So they wanted storage all pooled together as a resource and many servers actually accessing it at the same time. That was how the SAN was born. So essentially, similar like the DAS, you had a very large storage with a lot of drives. This time even more than before, but the key difference here is the storage has to be shared. And you have multiple servers connected to it at the same time. As it evolved further, we also had a device called the NAS, or Network Attached Device. Today I'm not going to talk too much about it, but I'm going to share with you how it actually looks like from a diagrammatic perspective, so you get an appreciation for it. It is very similar to the SAN, as you would have very large storage with a lot of drives. But the difference here is, instead of presenting volumes or capacity, it actually presented folders. And in those folders, multiple files. And this typically is connected over a traditional IP network, and it could be also your laptop or just normal servers in general. But instead of creating volumes, it stores files. And this is what we call the NAS. Okay, let's get straight into the hardware of a storage area network array. You will get the enclosure, the first main enclosure. It comes in what we call 3RU or 2RU. So essentially 3RU, 2RU just simply means rack units, and that's kind of defines how much space it's going to take up in the rack in the data center. So more often than not, the first enclosure is 3RU, and it consists of multiple drives. The drives could be SSD or just traditional hard drives, and it typically also consists of at least 2 controllers. The controllers function as the brain of the SAN, and the reason why there's 2 is for redundancy purpose. In case controller 1 fails, then you have controller 2 to pick up the slack. The whole theme about redundancy is very common as we discuss storage area networks, because everything that we talk about in storage is literally kind of based on redundancy. So how do you actually scale the storage? Very simple. You keep adding shelves. And as you add shelves, you populate more drives. What we do then is to connect those drives together using a cable. This cable could be a coax cable, could be network cable, could be all kinds of cable, and again, it varies from vendor to vendor. Built into the drives are also a lot of redundancy. So one of those mechanisms that we built in is actually RAID redundancy, or redundant array of independent disk. So there's various RAID types. There is RAID 1, RAID 10, RAID 5, even RAID 50. So depending on the type of RAID that you require, you can kind of carve it out into the array. So the RAID forms a pool of capacity, and within it, it has got some level of redundancy. It's also not uncommon to actually have what we define as hot spares. When a drive fails, that drive automatically kicks in and becomes the spare drive. But one of the more common ways of creating performance out of a storage area network is actually through what we call striping. So essentially we write data across all the drives. I'm just illustrating on one enclosure. There are some technologies that actually write across the entire array. So think of it as many drives working together to deliver performance. So if you compare this to what you have in your laptop, it's only really one drive that is working. So in an array, this could be potentially hundreds of drives working to deliver a workload. So next, we're going to look at how the connectivity actually works. So I'll just draw out two servers here for ease of discussion. And within these two servers, we usually have a thing called the HBA. HBA actually stands for Host Bus Adapter. Host bus adapters are essentially pretty much like what your network card is, but think of this as network cards for the storage area networks. It is specifically used for connectivity to the SAN only. So it's very common to have at least 2 ports on each host or each server that connects to the network, and I'll share with you in a while why. So similarly, on the storage, you will have ports. Most storages have 4 ports to up to sometimes 16 ports. So in this case, I'm just drawing an array with 4 ports. So what you can potentially do is to connect directly to the array, and that will work. No issues. But if you look at this particular diagram, it's not a very efficient use of ports, so to speak, because in this instance, you can only connect 2 servers. If you want to kind of stretch it out to 4 servers, you could. So each server has 1 connectivity. Again, if you remember, I talked about redundancy. The reason why there's 2 connectivity is also for redundancy in the event that 1 port fails. So how do we go about this? We create a switching network, much like a traditional IP network. Now, as you can see, you can actually connect it to 1 switch each, and then to the storage, and likewise on the other host. This way, you can connect more than 2 servers. You can connect as many servers as you want as long as you have enough switch ports. So switches come in various sizes as well. It comes in 16 ports to 32, up until what we have the directed class switches that can contain up to 256 ports. So if you're wondering what protocol is being used on the storage area networks, it's actually what we call FC, or fiber channel. So coming back to the diagram, just want to kind of share why we connect it the way we connect it. Spoke about connecting 1 here, 1 here, 1 here, 1 here, and likewise on the switch, we connect it to the controller. It could be a dual connection. Everything in storage is about redundancy. So it is very common for us to have 2 separate networks completely isolated. So in this case, you have 2 separate switches connecting to 1 controller, and 1 HBA card port connecting 1 controller, and then the other redundant one going on the other side of the controller. So in this case, we have 2 separate fabrics. How does the server then know which path to take? Because now you actually have 2 paths, or even more than 2 paths to take. So let's draw out the server again with 2 ports, and then 2 switches and the storage. The software that's typically used for path selection is a software called Multipathing. It's typically included as part of most modern day OS, but assuming you're running a very old system that doesn't come with multipathing software, the storage provider typically provides it anyway. As part of the multipathing software, they usually have 3 different policies that you can pick from to determine which path is preferred. The first more common one is what we call round robin. Round robin is, as the name suggests, you shoot down IOs 1 path at a time. So it takes turn and just goes round robin. The other one is what we call least used path. So the software will then pick a path that is least used or less busy. Because sometimes what happens is that you might have multiple storage subsystems or multiple storage that this particular host is connected to. It will just pick one that is not very utilized. And the third one is preferred path. So you can actually make the host take a particular path as primary and the other one in the event that the primary fails. So that is the 3 more common multipathing policies that you'll find in most software. So the next concept I want to talk to you about is actually zoning and LUN masking. So these 2 concepts are one of the very important concepts when it comes to security and access on storage area networks. So what you must be thinking is that, hey, you know what? I have all these servers connected to all the storage. Does that mean every server can see all the capacity and all the storages? The only way you can kind of stop a particular host from seeing volumes or datasets of other servers is actually through LUN masking and also zoning. So in this instance, let's for example say you have this particular server that only needs to access this storage here. So what we do is that we will create a zone profile and we'll include the ports, and each port has a unique identifier, much like a MAC address. So in the world of fiber channel, it's called WWN or worldwide name. And you take both the port's worldwide name and you put it into a zone, WN, and you also include the port worldwide names of the array. By doing that, this particular host will only have access to that particular storage. What happens if multiple servers still access the same storage? Wouldn't that server be able to see everything? Yep, that's true. So that's where LUN masking comes. So LUN masking is a configuration that is created on the storage where you actually define the volumes is mapped to whichever the host may be. So in this case, you can define a LUN mask to actually map against this particular server. So as you can see, there are two areas where you kind of need to make configuration changes to ensure that the right host and right server have access to the right storage. LUN masking is a configuration you do it on the array, and zoning is a configuration you do on the switches. Now I want to introduce you very briefly to something that is more in recent times called iSCSI. Essentially, iSCSI is exactly the same as fiber channel networks. The only difference is that instead of having these links being fiber channel, iSCSI actually uses the traditional IP networks. The reason being simple: cost. So when we first started, the performance wasn't all that great because networks were much slower. So you have 1 gigabits per second. But as times have improved and technology improves, today we are looking at networks of 10 gigs, 40 gigs, 25 gigs, and more than that. So today, iSCSI networks is starting to become a very dominant storage area network replacement for fiber channel. Much part because you can also use the IP switches for traditional IP traffic on top of storage network traffic. Hopefully, that quick tutorial was helpful in helping you understand a little bit more about how storage area network, or SAN, works. If you like this kind of content and want to see more, do let me know down in the comments. And as always, thanks for tuning in, and I'll see you on the next one.